Talking with TOPDON. Today we're going to do a video showing you how to clone the transmission control module on a ZF 9HP transmission. Now, in this particular video, we're going to cover a specific vehicle. However, many of these steps in the cloning process will remain the same on other vehicles that use this transmission. We are also going to cover updating the software on this transmission control unit using the RLinkLite as well. Let's go ahead and get started. So today's vehicle is a 2021 Honda Passport. So just a couple of notes about the 9HP transmission. It's actually used on a pretty wide variety of different vehicle applications, including Stellantis vehicles, which includes Fiat, Alfa Romeo, Dodge, Chrysler, and Jeep applications. Honda and Acura also use this transmission. Nissan and Infiniti use this transmission. Land Rover and Jaguar, MG, and Opel. And of course, there are always possibilities that there are other manufacturers I'm not aware of that are using this transmission as well. The earliest application we typically see of this transmission began around 2012 to 2013 model year vehicles. Now I'm going to move my little bubble so you can see everything on the slide here. It's important to understand that many modern transmissions have very specific fluid requirements, and the ZF9HP is no different. So the current prescribed fluid for this from ZF is the Lifeguard 9 fluid, or you can use the vehicle manufacturer's recommended fluid. So if you're dealing with a Honda, like we are here, then we would want to use the appropriate Honda fluid as called out in the parts catalog from Honda or the service information. Many software updates have been released for this particular transmission through each vehicle manufacturer. That means those software updates are vital to ensuring the optimal functionality as well as longevity of the transmission assembly itself. That's why we're going to show you the update process on this Honda after we complete the cloning process. It's also important to note that there are a wide variety of aftermarket shift kits and other component level upgrades internal to the transmission that may be worth examination if you have experienced a failure of this transmission assembly. If you are a consumer, it'd be a good idea to ask your transmission rebuilder or shop that is servicing your transmission to explore these opportunities to improve the transmission hardware. It's also important to note that a large number of vehicle manufacturers have issued recalls and technical service bulletins on this transmission. You'll want to check service information and all of the technical service bulletin databases to verify if there are any bulletins applicable to your specific transmission. So today's tools we're going to use consist of the TOPDON T-Ninja Box, which we see here on the bottom left, and the RLinkLite on the top left, as well as the LaunchTech branded PC interface, which is cross-compatible with the T-Ninja Box. We're also using a Windows-based PC that is approved specifications as per what the Honda special information says regarding using their diagnostic and programming software. So to obtain that information, you'd want to go to the Honda Tech Info website and look at the system requirements before you choose a laptop to use for that part of our video. We also purchased a short-term subscription from Honda to use their factory diagnostic and programming software with our RLinkLite. So today, we're going to clone the TCM or transmission control unit. Why are we performing a cloning on this particular unit? This unit is external. So in theory, we could just unbolt it and bolt it onto the used assembly that we're installing. However, one reason why cloning is a good idea here, and this particular tech tip is thanks to the gentlemen Tim, Ira, James, and Mike at autotechelec.com. They are experts on the module cloning and module internal repair stuff. So they had provided some insight that these particular transmission control modules actually suffer hardware failures sometimes internally. So because we don't know if the transmission control module is okay or not from a hardware perspective, such as the drivers, any of the sensor electronics, or anything like that that's internal to the module, we're going to clone the module and update the software on both the original and the donor to make sure that we have two possibilities as far as modules that should work in the car. So that way we have two chances that at least one of the two units is going to be functional. So I'm going to shift my bubble back to the bottom right here. So one moment. So we're just going to outline the process steps here for our video. We're going to review the service information, and I'm not going to walk through that, but you need to do that. We're going to look up and make sure that the two modules we have, both the original and the donor, are identical. So we got to check our part numbers stamped on the module. We're going to set up our T-Ninja box and the PC interface in a safe, stable place where we don't have to worry about people tripping over the cords, accidentally unplugging it, bumping our connections, anything like that. We're going to connect the T-Ninja box to the original module. We're going to read the EEPROM data and the flash data at least twice each, and we're going to save them as versions 1 and versions 2. And then we're going to compare the data for consistency to make sure that when we read the EEPROM data twice, both files are identical. And when we read the flash files, both files are identical. Then, once we've verified they are identical, we can disconnect the T-Ninja box from the original module, press the button on the software, then physically disconnect. Then, we're going to connect the T-Ninja box to the donor module. We're going to connect just like we did to the first module, the original module. This time, we're going to write the flash data and the EEPROM data to the donor module. Then, as a prudent extra step, and this is not required, but it is advisable, we can read the data back from the donor module after we've written that data, verify that what we read back is the same as what we thought we wrote to it. Once we verified, yes, that's true, then we can disconnect from the donor module. Next, we're going to check the TCM for software updates using our RLinkLite and the Honda i-HDS software, which we have purchased a short-term subscription for. Then, after the transmission is installed into the vehicle, the TCM is plugged in, everything is put back together, we've verified that the fluid level is full and appropriate. Then we need to check our service information once more to verify if there are any relearns or adaptations or anything of that nature that need to be performed before we release the vehicle to the customer. So now we're going to get into the steps in a little bit more detail here with some screenshots. So we're going to gain access to both TCMs, the original and the donor. We're going to look at the part numbers on both the original and the donor. Make sure they are identical. You'll see this is where they are stamped on the TCM itself. And we have verified that both our original and our donor are identical, so we can proceed forward with this job. So now we're going to connect our T-Ninja box with PC interface directly to the original module from the original transmission. Once we have it all set up, as you can see we have here, so we got our T-Ninja box right here, we have the PC adapter plugged in right here, we have our USB cord going to the PC, we have all of our cables connected to the module, and we're going to show you the wiring diagram, so just be patient. We always want to make sure through our process that we check all of our connections, both at the module, as far as on the individual pins, as well as the numbered pin assignments, which you will see in the wiring diagram in a moment. You also want to make sure your power supply going into the T-Ninja box is stable. So once we boot up the PC software, we're going to search ZF9HP in the search box. Once we find the ZF9HP software or the selection menu, then we're going to open it up and we're going to get this menu here. We're going to get direct connection diagram. So that's basically going to give us our wiring diagram. So we're going to hit that button, load the wiring diagram. It's going to open the wiring diagram and we'll have our pin assignments here. So what we have is the T-Ninja box numbered connections. So on the T-Ninja box breakout cable, there will be numbers. Those numbers will correspond with the numbers you see pictured above the given pin at the module. So number 1 cable from the T-Ninja box breakout cable will go to this pin number 5 at the module. And then you just follow each of these to do those same connections as you see here. So cable number 5 goes to pin 9, cable number 10 goes to pin 1, etc., etc. Okay? So now, once you've made all those connections and verified they're all nice and snug on the actual pins at the module, now we can establish connection to the module through the software. So we're going to hit the connect button up here. Once we've hit the connect button up here, we should get a message that says succeeded here. Once we've established the connection, now we're going to read and save the EEPROM data twice from the original module each. And we're going to save them as versions 1 and versions 2. So first, we'll read the EEPROM data here on the top. Once we hit that button, it's going to start downloading the file from the module. Once it's downloaded and completed the read, it's going to pop up a window and you're going to be able to save it. Now, I usually save it OG for original module, and then the number 1 for the first time I read it, and then additional numberings every other time I read it. So usually OG1, OG2. And I save those files accordingly. So here, this is the first read. We're going to save it, OG1. Then we're going to do it again, OG2. Again, we're initiating the read process a second time and saving it. Once we've saved the EEPROM data, now we have to go save the flash data. We're going to read it twice, just like we did with the EEPROM data. So we're going to read flash data. And again, you're going to see it start downloading the file. It's going to pop up a window and we're going to save it flash OG1, save, and then repeat the process again, save it OG2. Okay, now we have 2 saves of both the EEPROM data as well as the flash data. Now we can disconnect from the module. So we'll press the button to disconnect the software. You should get a confirmation after you do that, and the confirmation will appear down in the bottom left. Now, once we've read the data, both the flash and the EEPROM from the original module, we have to go back and we have to compare the files to make sure they are in fact identical. That means we got good data read from the original module, right? Or reasonably we can feel that we did. So now we're going to use a program called HXD, which is completely free. So if you Google search that, you can find it. And basically you're going to use HXD to compare the 2 files. So we load the EEPROM data OG1 and we load the EEPROM data OG2. So those are the 2 reads of the EEPROM data we made from the original module. And then we're going to compare them. And once we compare them, it'll tell us if the files are identical. Once we get this message that says the files are identical, we're in good shape. So now we would do this on both the EEPROM data as well as the flash data, and we want to make sure we get the same message that the files are identical. Once we've established that they are indeed identical, now we can proceed forward. The next thing we need to do is go to our files on our PC, find your program files x86, the YCG3 PC folder, and the data folder, and rename all your files .bin as in binary. The suffix does not get attached to the files automatically, so you do have to add that. If you do not add that, you will not be able to locate the files when you attempt to retrieve them for writing them to the donor module. So we're going to reconcile that, add the .bin on the end of both the flash and the EEPROM files. Then we're going to connect to the donor module using the exact same process we did to connect to the original module. So pin it out after referencing the wiring diagram, hit the connect button on the software to initiate the connection to the module. And then once we have established that connection, now we're going to write the EEPROM data to the donor module. So here we're going to use write EEPROM data. Once we have, again, remember, we had to connect first. Then we're going to write that EEPROM data to the donor TCM. Once we write the data, we're going to have to choose a file before we can write it. Just a note there. So when it asks us to choose our file, we just want to choose one of the two EEPROM data files that we read. Remember, we checked them to make sure they were identical, and they were. So it doesn't matter if we choose OG1 or OG2. Whichever one we named that we prefer, they're identical. So it doesn't matter. So we're just going to choose OG1 EEPROM data. We're going to hit open, and then it's going to initiate the writing process. Then, once it has completed the writing process, and of course your progress bar on the bottom here will progress as it writes it, EEPROM data is usually fairly fast to write, usually doesn't take a very long time. Typically the flash data is what takes longer. So you should get a confirmation that says the data was successfully written. Now we're going to do the same thing, but we're going to write the flash data. So now we're still connected to the module. We already did the EEPROM data, as you can see. Right here in our log file, it says write EEPROM data was successfully written. So now we're going to click write flash data. And again, the software is going to prompt us to choose a file. So here it's going to say choose a file. So again, we checked OG1 and OG2 flash files are the same. They're identical. So it doesn't matter which one we choose. Once we choose it, we're going to hit open. The flash file writing process will initiate. Your progress bar will take some time to progress. Again, the flash files can take a little bit longer to write, so be very patient and do not disrupt the software or the hardware in any way until you get a confirmation it's done. You see here we have successful confirmation, which means we have successfully written the data to the module. Now, again, you do not have to do this step, but it is obviously a prudent measure. While we are still connected to the donor module, we can read the EEPROM and the flash data now after we have written the new files to it. And when we read them back, we can save them as post-donor cloning and compare them to the original files we retrieved from the original module. This is just one more way to verify, yes, the information we wrote to the donor module is in fact identical with the information we retrieved from the original module. Once we've done this, now we can disconnect from the module, the donor module, using our disconnect button. Once we get a confirmation that says disconnection successful, we are now done with the cloning process. So, what do we do next? As we mentioned at the beginning of our video, the ZF9HP is well known for needing software updates to address a variety of concerns, not only tied to shift quality, but longevity and overall performance. So we want to make sure we're checking this transmission control module for software updates. How are we going to do this? We're going to use our RLinkLite, and we're going to use a subscription, a paid short-term subscription to the Honda i-HDS software to update the software on the TCM, or at least check it to see if it needs any software updates. Now, in order to perform those updates, you can perform the updates on the bench with the transmission control module and a breakout box. This would be something for advanced users only. Most users, your best practice and the preferred way is to do it while it's mounted inside the vehicle. So here is just a picture of doing it on the bench. So in the picture, we have the breakout box. We have a 120 ohm resistor in series with the module. We have the TCM connected here. And then we have our RLinkLite plugged into the breakout box. And the RLinkLite is also plugged into the PC where the Honda software is located. So now we're going to show you how to connect Honda's software with the R-Link and connect the R-Link to the car and check for updates. So here, we've purchased our subscription to Honda's software, we've downloaded it, we've installed it. Now we're going to launch it from the desktop right here. So we're going to double click on the icon. You're going to get a prompt that's going to offer you a choice. So you got to choose your vehicle communication interface. Of course, we're going to choose our R-Link, and then we're going to hit the start button here. You're going to get another window that pops up that shows Honda Diagnostic System, which is just telling you it's launching. Then you're going to come to a screen like this. On this screen, we're going to choose Honda ECU reprogramming. Next, after we select Honda ECU reprogramming, we're going to get another pop-up that shows this. Our other screen will disappear, and eventually you will come to a screen like this. Now, when you get to this screen, you're going to click Read Vehicle Information, and the software is going to retrieve all the information from the vehicle. Now, it will take a period of time to retrieve this information. Make sure you verify that the VIN number it reads here matches the VIN plate on the vehicle. If it does not, you may have a VIN mismatch in one of the modules in the vehicle. We're not going to talk about that today, but just be aware. Once you see that it matches up with your VIN and your mileage matches, the software will automatically check all of the modules it can communicate with to check them for software updates. Now, in this particular case, we did not have the transmission control module plugged in, which is why you do not see it listed here in this particular screenshot. So we go to the next screenshot, and here we do have the TCM connected. And you can also see that the software recognizes the software is fully updated. So we do not need to perform a software update on the transmission control module for this vehicle at this time. However, again, it's really crucial that we check for this when we are dealing with the ZF9HP transmission. Of course, that applies to all vehicle manufacturers, regardless of which brand. The software which you use to update that transmission will be different based on who made the vehicle itself. So, we checked it for updates. We've successfully performed the cloning. What do we have left to do? We need to verify in service information if there are any additional steps necessary when the transmission assembly has been replaced and or the transmission control module has been replaced. Of course, this is a replacement used transmission that was installed in this particular vehicle. The transmission control module was cloned, so all of the stored information as far as adaptations goes is not going to be correct for the used transmission we have installed in this vehicle. That means when we go look at the Honda service information, we find there is a calibration procedure that must be performed. So, in order to perform this procedure, we need to make sure that the vehicle has everything properly installed, transmission is fully installed, it's full of fluid to the proper level. Of course, we want to look at service information for the level check procedure. We want to make sure that it's within whatever temperature specification that the vehicle manufacturer tells us. And then we want to perform the relearn procedure. Now, this relearn procedure can be performed using a TOPDON Phoenix Professional Series tool, or you can also use your RLink and the Honda factory software. So either one is going to work just fine for this process. Remember, when you're doing relearn procedures on any modern transmission, in most cases, after you initiate the procedure with the scan tool, there may be a period of time that you need to wait before driving the vehicle while it goes through a variety of calibrations, essentially just sitting in the bay. And many vehicles will also require that you drive the vehicle for a period of time after the bay procedure is done. That will reform the calibration of the shifting for the transmission in most vehicles. It's also important to remember that when you take it for a drive after the procedure has been carried out in the bay as per the service information, the relearn process as you drive it can take time. So it's very important that you have this communication with the customer. Again, this can be done with any TOPDON Professional Series tool and or your RLinkLite and the Honda software. It's going to take time for the shifting to smooth out after you've performed a relearn like a hydraulic pressure calibration as we saw here. So remember, if you're not going to do that driving as a technician, you want to warn the customer it's going to take some time for the shifting to smooth back out. That is normal. It's also important to remember you want to verify that as you're doing that driving, no fault codes are setting that would indicate there's a problem with this replacement transmission. So, We've taken you through the process here on the ZF9HP on the 2021 Honda Passport we worked on today. We showed you how to clone this particular transmission control module. We also showed you how to perform a software update using the Honda factory software and your RLinkLite. So, hopefully you learned something today, and hopefully you can share this video with other people so that they can benefit from it as well. As always, we really appreciate you taking the time to watch our videos. I'm Hawken with TOPDON. Please like, share, and subscribe, and we'll see you on the next video.